Looks maybe a bit intimidating and looks like very complicated, but it's actually very, very simple. The code is very simple, and I'm just showing you, like I said, a microprocessor and how it can control like a small project like this. So what I'm going to do is I'm just going to plug it in if there is a closer plug. If not, I'll try and move it over.
I'll assist you with that.
Thanks, man. But there we go.
Do you need power extension?
Don't think so. Brilliant. All right, so.
If you do, we do have power extension.
No, it should be able to reach. So basically, what I'm simply doing is this microprocessor has a couple of ports for the X, Y, and Z axis, and then you've got another one for a motor that pushes the material. Okay. What I'm just going to do is plug this in here. Now, I'm going to allocate this motor as the X-axis, and I will just stick that into the X-axis port. Backwards. I'll plug this into the Y-axis. Plug obviously the LCD screen in there. And we'll switch it on. Alright. So this is actually the same LCD and controls on the 3D printer, same microprocessor. Basically, what I've done here is just use the 3D printer to print the parts. And what we can do is we can go to the move commands, same commands that you're sending to the 3D printer, like I said. I bet you can see them actuate. Oh, oh, sorry. So what's happening here actually, and somebody who is more into code, I'm not actually a coder myself, but what's happening here is it's sending the commands to the motors, but then what's happening is once the command is finished, the motor doesn't lock, so it just collapses on itself. So there are actual codes that you can put in so that once the command is finished, the motor will lock in place. Okay? That doesn't have this in the microprocessor because in a 3D printer you don't want it to lock after a movement. But you know, this is like simple code that we can just type into G-code and send it over a web UI. So, oh, there you go. There you go. So that's just in the X-axis. Remove the Y-axis. So it's pretty straightforward again. There we go. Why is it not going further? In 1 second.
So have you printed the hand by yourself?
This is all printed on that small printer, yeah.
Awesome, that's really awesome.
As you can see, yeah, there's still a couple of things. I literally finished it maybe 2 days ago, so there's still a couple of bolts missing for this. That's why it's falling apart. I still have to write the correct code for this program. I'm using a code that obviously actuates the motors, but isn't optimized as it keeps collapsing on itself. But that's the beauty of code, right? The other things that I wanted to show you, other than this project, is actually another 3D printed part. So this comes from a website, and I can probably get up the website very quickly. Some of you will know more than I would, certainly, what the code behind it is. But it's very simple. It is geometric shape that on the website that you can change certain parameters. So you can make it bigger, you can make it smaller, you can change the inner design, and then you can basically just simply download that 3D model. So you don't need to actually know how to 3D model. And that's the beautiful thing about this. So this is actually a small bracelet that was 3D printed, and it was printed in all in one piece. It was not assembled later on, so you can actually just take that off the bed and it comes as it is. And the programs basically that do that. Oh, I'm not connected to the internet.
The password is Zala1234.
What's the Wi-Fi name?
Hall something 1, 2, or 3. The one that has the strongest connection.
Conference hall 1, 2, 3. Okay, 1 and 2. And the password is, sorry?
Zala, Z-A-L-A 1234.
Okay. So basically, what I'll do is I'll show you that website, and I'll talk a little bit more about that. The other thing I wanted to show you is this. It's called a lattice cube. And what's quite interesting about this is it required no support material. Quite often, with parts, you actually need support. So if you're printing, let's say, this finger, and you're printing it at, let's say, this angle, according to the bed, they will need support here because you're printing out something that's molten. It's 210 degrees. So it's basically liquidizing the plastic. And then it deposits that in a layer by layer fashion. Now this didn't need support because if you actually have a very, very quick look, and you can all walk around and have a look at it, but you'll see the orientation and the layer lines, okay? And what's impressive about this model is that it is a lattice structure that supports itself. So it's actually derived from nature. So the way Mother Nature designs is obviously the most optimized design and code, really, in a manner of speaking, that you can do. And that's basically what this is showing, is that it is an extremely complicated structure, but it requires no support because every single angle supports itself. What's also very impressive about this, and why I wanted to bring it today, is because this would be impossible to manufacture any other way other than 3D printing. There is only one other way that you can manufacture this. You can't make it by hand, because you cannot get any tool inside to create the structure internally. You can't use injection molding, because injection molding is what's called unilateral limitations. It is a male and female mold, and that pulls apart in one axis. Okay? Sometimes you can have pins, but you would never be able to get the geometry internally. The only other way to do this is what's called sand mold, or sand casting. Right? But that is a destructive mold. It costs minimum €2,000 to produce one part. You can't continually produce this, okay? That cost, the printer is less than €300. The amount of material that's used is less than €5. Do you know? So from one printer, you'd be able to print roughly 2,000 hours of printing. You'd be able to produce more than 200 parts, 200 of these, for less than, let's say, €500, instead of 2,000 for one piece. So that's what's important about this structure, is that it is impossible, really, to manufacture other than 3D printing. Now, as designers and coders, basically, I'll show you, you might not be designers. Is anyone also a designer as well as a coder? Like, do you have any 3D modeling experience? If not, it's no problem. Obviously, we're here as coders.
You should join our course at Beehive.
Yeah, exactly. There is a course at Beehive, actually, from the very beginning for beginners, right? And then you have like more intermediate and expert levels. But for 3D printing, the biggest limitation is design. So how do you get the design? You have an idea in your head. How do you materialize that? As a designer, it's important that you design for 3D printing. So like I said, this structure requires no support, and that's what you want to achieve as a designer. And it's the same here. This structure here was printed in this orientation. Quite difficult overhangs, quite difficult geometry, but are again supported all itself and required no support. So this is actually one of the best examples, and it wasn't in my design. It's a designer from San Francisco who designed this, and it's just a simple Christmas ornament. Okay, it goes in your Christmas tree. But what's really, really impressive about that is that, you know, the geometry is so complex, and yet it prints beautifully, straight off a printer, requires no support, and he's thought of every angle in the design. So this is what we refer to as the most optimized design that you can possibly do. But again, like I said, with a bit of code as well, you can take something very complicated like that and just manipulate the code, so that, you know, you can increase it or decrease it. So what I'll try to do is neural systems, 3D nerve systems. So basically, this is the company here, okay? And if you go to, let's say, they have a website here where you look at different designs like this, okay? And they, as designers, have designed that and allowed you on the fly on the website to simply change the parameters to fit different people. So this fits my wife because she's got very, very small wrists. It would never fit me in a million years. But I can change that parameter by simply just manipulating the X, Y, and Z. So if I go to jewelry, I'll try to find it. Yeah, they're selling jewelry here. Create your own, okay? And this is exactly what I'm trying to show you. So that's kinematic bracelet. So here you can see it's loaded up the bracelet. Now, it allows you by simply just pulling on parts to design something on the fly like that. All right. Down here, you've got different designs that you can do.
Can you turn also a bit around?
No worries. So you can do different designs here. You can obviously specify the color and see it in different colors. And you can also specify the dimensions and the size. So you can simply, if you're looking to 3D print a bracelet for a girlfriend or your wife or whoever it might be, you just measure their wrists. You can do this on the fly. You don't need any design experience. There are a lot of websites that allow people who already have a 3D printer. There are, I believe, it's called 3D hubs. I believe there are 8 people here in Varna who have 3D printers at home that open up their service. So they'll print it for you and they'll charge you like €2–3, whatever it might be for the part. So you don't actually need to invest in 3D printer immediately. You know, if you wanted to print one part, you can go onto a website like this, you can manipulate it, you don't need to know you don't need to know anything about modeling. And what fascinates me as a designer is I have no idea how basically the algorithm can control the design. But that's extremely impressive, and that's why I wanted to bring it today, because some of you brighter minds in coding might actually understand the code behind that to be able to manipulate it. But as a designer, it's fascinating for me because I do that from the hard work. Yeah? I have to literally model every single part of the geometry myself. Whereas to be able to use an algorithm simply to offer customers a way to customize my design is absolutely incredible. So the more people adopting 3D printing, I think there's more potential for coders like you guys to look at the limitations, which is design, and then to basically adopt that and to tackle that with a website like this, where you can offer 20–30 designs, manipulate it, change it, you know, for people who don't know how to 3D print, or sorry, how to 3D model, and then they can 3D print it either through a service or through their printer at home. So this, again, I think we need more. We need more of that in the industry. We need more coders to look at the potentials of 3D printing. Another example, which is very, very cool, unfortunately I couldn't print it on time, but it's what's called velocity printing, okay? So, like I told you, printing is very, very straightforward. The concept is you simply deposit material in a layer-by-layer fashion. So I believe I have a PPT that I did previously. And I'll show you very, very quickly like the basics of what 3D printing is. It's very, very straightforward.
Do you want to connect it to the projector?
I can, but I don't know. Can everyone see it? No? Maybe, yeah? It's only very, very quickly. I think some of you may or may not have actually been there already. Hang on. Presentation. But, you know, just for some people that may or may not know a little bit about 3D printing, I'm just trying to find it here. My apologies for that.
In the meantime, can we look at the stuff?
Yeah, pick it up, have a look at it. This is also a project actually that we're doing now in Varna. There's a young girl, about 7 years old. We're working with her. She's living here in Varna. She was born without any fingers, so it's a birth defect. That's actually more common than we know. I believe in America the statistics are 1 in every 100 babies born actually have this defect. It's much, much more of a, well, let's say, not a problem, but certainly it's more widespread than we know, okay? So these kids, they go through their life and they have this defect. The unfortunate thing is, this girl's 7 years old, all right? She goes to school. At 7 years old, her other friends have no filter what comes out of their mouth. So they don't mean to be rude, but my wife is the teacher and they all look at her hand. She's very embarrassed. She always has it in a pocket because she doesn't want people to see that, because at 7 years old her friends are going, ugh, you've got a horrible hand, you know, and that hurts her feelings, of course. So she's very ashamed of it. So what is amazing about this project, it's a company from the UK who open source, who give the design away for free. Okay, they're called Enable. And what you do is you can 3D print this entire piece. So this is all 3D printed again on a small printer. It costs less than €7 in material. Okay, and it just changes. It gives her a little bit of dexterity. So the idea is that she has her hand in here, and then by simply bending her wrist, it's able to give her a little bit of dexterity, and it's all very, very simple mechanics. You know, very simple use of tension. Now, what's most impressive about this project is that it's not giving her a full arm. She'll never have an arm again, okay? And it gives her a little bit of dexterity. It gives her a little bit of help so that, you know, she can pick some stuff up with 2 hands, etc., etc. But what's really impressive about this is it changes the conversation in school. So instead of her classmates saying, oh, you've got a stump, they go, cool, you've got a really cool arm. Yeah? And there was even a joke my wife told me that she was demonstrating this to the kids, and one of the kids are like, oh, chop off my arm, I want this. So that's obviously not what we want. but the point is that it changes the conversation.
Star Wars fans.
So, well, yeah, exactly. Well, one of the kids are like, can you make an Iron Man hand? And actually that exists. There are designs. This is only one of maybe 20 or 30 different designs that are open there for free. You can download the models for free. And there are lots of different companies that basically donate their time and their printer to print it. So this company in the UK, they do a lot of designs, they give it away for free, and then they open it to people around the world who might have a 3D printer, who might have spare material. So what I've done is I've printed out maybe 5 or 10 of these hands. And what I've done is I shipped that to the UK. They paid for the shipping. And what they do is they collect it from all around the world and they send it over to Africa, where they don't have 3D printers, they don't have electricity, they don't have the medical, basically, support there. And it helps in a huge, huge way. And it's a beautiful way to do it. So, you know, you're showing, what this is showing is that 3D printing is a great hobby as an individual, but it actually can really affect people's lives in a very, very positive way. So as I said, like very, very quickly, basically, you know, if some people don't know what 3D printer is, printers can come in a very, very large format, what's called industrial 3D printers.